Second program is develop a program to compute the correlation matrix to understand the relation pairs of the features and visualize the correlation matrix using the heat map to know which variables have strong positive or the negative correlation, and create a pair plot to visualize the relationship between the features and use the same California data. First what we are going to do is correlation matrix. Correlation matrix, a correlate to plot a correlation matrix. Correlation matrix is nothing but it will compute the correlation or the relationship between the different features of the data set. It shows the relationship between all numerical features in the data set, and if the value is ranges from -1 correlation, negative correlation is positive, the value is positive, then features between the features, and if the value is 0, then there is no correlation. There are three features, so there are three relationships between the numerical feature, either it is positive or it is negative or it is 0 or no. So that can be done using the heat map. Heat map is nothing but for the positive or the strong relation, the will be giving the warm colors to represent for the here consider. So this is the heat map. So here the relationship is positive and it is 1. This is the strong relation. Here the color is warm. And for the negative correlationship or the weak relationship will be the color will be cool. So this is called as heat map. So same thing, and we at last we will be creating the pairwise relationship and between the features, and we'll be using the same California housing the data set as we have used in the first program. So for pandas, import pandas as PD. So that is used for pandas is used for data manipulation and next is Seaborn. Seaborn is used for, it's a data visualization library based on the and matplotlib creating this used for creating this or animated or as well as interactive visualizations. And scikit-learn, sklearn is nothing but scikit-learn. Scikit-learn is a Python library, the most popular Python libraries of, and it will learning, and it will tool for efficient tool for providing pre-processing is of data, cleaning of data. For example, some spaces, some there is some uh, values, numerical values like some special symbol of data, meaning of data can be done using this library, and model selection, training, valuation. So all these things can be done by this sklearn. So first is we will be loading the California dataset as a data frame, means loading it as a CSV file, means rows and columns, and we'll be storing it in the data and be using the data.rr, CORR, means on this data frame will be called means correlation function in order to compute the relationship between the different features, and will be stored correlation matrix. And then similarly, as we have plotted for the histogram and the bar plot, will be giving the figure size, and from the SNSC bond will be calling the heat map function and will be passing the correlation which is having and annotate equal to true means render the means plot this, annotate this correlation matrix. And then CMAP is nothing but color should be warm for positive correlationship and cool for the negative weak correlationship. So we are defining that to in width to 0 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 to 0.5, and should be correlation for the California housing features. Finally, we will be rendering the heat map using the plt.show function. Similarly, we will be plotting pair plot and will be passing this data means it is a having the data frame of California data set, and the kind will be KDE as I have already explained. It is a kernel density kernel KDE. So it is used for smooth. KDE is nothing but the kernel density estimate plot. It will create the smooth curve to represent the distribution of the data, and then alpha equal to 0.5 is nothing but make the transparency of the scatter plot to 50%, and then we will be giving the subtitle, and then we finally will be rendering the pair plot as well. So this I have executed using the same Jupyter notebook. So this is the program I have executed, and this is correlation matrix of California housing features. So between median income and between median income, so there is a positive correlation, means both are having the strong relationship, because at the diagonal you can see all the correlationships are 1. Okay, then between the house age and between the between the between the average rooms and income, so there is no there is a less relationship or the weak relationship, right? So it is 0.33. And between the average bedrooms, average number of bedrooms, there average rooms, there is a some relationship, because average number of bedrooms is also comes under average rooms only. The relationship is 0.85. And for the negative correlationship, for example, house age and population, so house age and population, there is no relationship between, is a negative, so it is a negative correlation and it is a cool color. And between the latitude and the longitude, it is completely different. Okay, so it is minus 0.92. So means there is no relationship between them. Similar plot will be plotting. This is the pair plot. Similar to that, similar to heat map, will be plotting the pair plot. So this is all about the second program.